We're now less than 5 years away from a moment nobody really wants to think about. The ISS, humanity's very first space station, will fall out of orbit and burn up, leaving nothing but debris. And if we don't have a replacement ready by then, China's going to take the lead in low Earth orbit. It'd be like openly folding in a high-stakes game. But that future isn't happening. Because Vast Space, a company that hasn't taken a single dollar of NASA funding, has just pulled off something huge. They've introduced Haven 1, the most advanced commercial space station module in the world. Soon, it won't just replace the ISS. It might also crush China's ambitions, right when they think they're on top. And that future doesn't rely on Vast alone. SpaceX is part of the equation too. If Vast is the bullet, then SpaceX is the gun that fires it. So, what exactly is Haven 1? At its core, it's a space module, similar to the ones NASA is funding right now, like Axiom Hab 1, Orbital Reef's Life Habitat, or Starlab's Habitation Module. All of them are strong contenders, each built with the ambition of one day replacing the ISS. But here's the difference. While those competitors secured hundreds of millions of dollars in government contracts, Vast didn't get any of that. They built theirs entirely with their own money, and somehow, their module is already way ahead. By July this year, Vast had completed Haven 1's primary structure. By October, they began the final welding work on the hull for testing and integration. And by the end of that same month, the whole module was rolled out to the Mojave Desert in California for structural testing. Sitting on its test stand, it looked bright, massive, and more flight-ready than ever. But they're not finished yet. Vast has completed 18 out of 22 major milestones, with full completion expected by May 2026, and they plan to launch it that same month. Oh wait, if Haven 1 is still in the testing phase, why are people so confident it'll beat every other competitor and become the station that replaces the ISS? Those remaining milestones aren't just checkboxes. If even one of the last 5 fails, Vast's dream could fall apart overnight. But maybe that worry is a little overblown, because recently, Vast pulled off something big with SpaceX, a full mission success that proves their ambition is real, and their progress is just as real. Before launching Haven 1, Vast wanted to be absolutely sure everything would work. So they built a test satellite called Haven Demo, a 515-kilogram spacecraft packed with the same technologies and software that will fly on Haven 1. It carried the propulsion system, the guidance and navigation software, the RF communication system, and much more. In other words, it was Haven 1, just in satellite form. And the good news? It was a complete success. Haven Demo launched on November 2, 2025, aboard a SpaceX Falcon 9 during the Bandwagon 4 rideshare mission from Cape Canaveral. Right after deployment, it unfolded its solar arrays, reached positive power, recorded 4K data of the entire sequence, and established initial contact with ground stations, confirming that every system was healthy. And honestly, the mission was such a success that the team inside Vast's ground control center absolutely erupted, just like SpaceX did when Falcon Heavy flew for the first time. It's a strong sign that Haven 1 will succeed too. And what makes it even more impressive is the timeline. Haven Demo went from concept to orbit in just 2 years, an insane pace for anything related to a space station. Most traditional station modules take 5, even 10 years before they see daylight. But Vast isn't here to move slowly. Their entire identity is built around one principle: speed through smart design. Unlike the old aerospace giants who get stuck in endless reviews and perfectionism, Vast moves like a startup in orbit, fast, iterative, and relentlessly adaptive. A lot of that mindset comes straight from their biggest partner, SpaceX. Instead of waiting for the perfect design on paper, Vast builds, tests, learns, and rebuilds. That's how progress works in this new era of spaceflight, through action, not hesitation. And to maintain this breakneck pace, Vast does almost everything in-house at their Redondo Beach facility. Their team is lean, just around 900 people, all focused on a single, shared goal. It's not just speed that defines them. Their success is also reflected in the partners they choose. Take their decision to launch on SpaceX's Falcon 9, for example. That's smart thinking. Falcon 9 boasts a 99.4% success rate across nearly 600 launches. And it just set a record with 30 flights using the same booster. Elon Musk even confirmed it on X. 30 flights of the same rocket. And yeah, the Haven demo satellite is planned to stay in orbit for 6 months, during which it will run a series of additional tests to minimize any risks when Haven 1 itself is launched into orbit aboard a Falcon 9 next May. Once in orbit, VAST's first operational space station will host up to 4 crewed missions over its 3-year lifetime. Each visit will bring 4 astronauts for 10 to 14 days, living and working inside the first commercial space habitat ever built entirely by a private company. The first crewed flight, VAST-1, is targeted for late June 2026, flying aboard SpaceX's Crew Dragon, which will handle both transport and life support. After that, the crew will live in Haven 1's habitable volume, which is about 45 cubic meters, roughly the size of a city bus. Of course, it won't feel cramped. In fact, it can even feel surprisingly spacious. Inside, the astronauts will have 4 sleeping quarters, a common area with large observation windows, a microgravity research lab, and a corridor for storing personal gear, all designed with a minimalist yet ultra-modern aesthetic, kind of like a 5-star hotel in space. But VAST's CEO, Max Hayat, made it clear, the focus isn't luxury, it's productivity. Haven 1 is designed to be a place where astronauts can rest better, communicate better, and work better. And none of that would be possible without SpaceX. They provide everything else: launches, transportation, training, and even infrastructure. It's a full-spectrum partnership. Falcon 9 handles the launch, Crew Dragon carries the astronauts, Starlink manages communications, and power systems are integrated across both platforms. SpaceX essentially provides a near-turnkey path to orbit. Together, they form the backbone of a new commercial space era. However, another challenge arises. Once Haven 1 is in orbit, it needs at least 1 spacecraft docked at all times. That role falls to Dragon, not just for transport, but also as a lifeboat and to help maintain the station's altitude, because, according to physics, it will gradually be pulled back toward Earth. Currently, SpaceX has 5 active Dragon capsules: Endeavour, Resilience, Endurance, Freedom, and Grace. Using just one to support Haven 1 could impact other missions to the ISS. In other words, over the next few years, the ISS will likely scale back some science and cargo missions to prioritize support for the construction of newer stations. Take Haven 2, for example. While Haven 1 is still essentially a test bed, Haven 2 is designed to be a true successor to the ISS, and its plans are nothing short of ambitious. Just like the ISS before it, Haven 2 will be assembled module by module in orbit over several years. The plan is to launch the first module in 2028, then continue expanding it until completion sometime after 2030. Once finished, Haven 2 will consist of 8 separate modules connected together. Imagine the scale. This isn't a bus anymore. It's essentially a small interstellar city, a massive leap from Haven 1. And to get a sense of what it will feel like for those living there, consider this incredible number: 12.5 meters. That's the width of the panoramic observation window, one of the largest ever built for space, promising views of Earth unlike anything we've seen before. So, where does the VAST and SpaceX project fit in the bigger picture? Well, it's part of a completely new commercial space race. The main driver of this race is NASA itself, through its Commercial Low Earth Orbit Destinations program. NASA has essentially changed the rules. Instead of building and running their own space station, they now act as a customer, renting space on private stations. This saves money and frees NASA to focus on more distant goals, like Mars. And this policy has ignited fierce competition, and VAST isn't racing alone. While VAST is making waves with Haven Demo and Haven 1, another competitor is picking up speed on the other side of the track: Starlab Space. On November 20th, Janus Henderson Group, a massive UK investment firm managing over $484 billion in assets, officially announced its funding for Starlab. The exact amount remains under wraps, but statements from Janus Henderson grabbed the industry's attention. They claim Starlab has the best design, the lowest costs, and the most attractive business model among the ISS replacement projects targeting post-2030. This isn't some small venture fund. It's one of the world's top traditional financial institutions, making its first major bet on a commercial space station. And it makes sense. Starlab is moving fast. 55% of its research capacity is already reserved, mainly for biopharmaceuticals and cancer drugs. The main structure has a contractor, assembly and testing partners are in place, and in just a few weeks, they'll enter a critical design review phase. With just one launch planned via Starship in 2028, Starlab will arrive in orbit as a giant inflatable station, backed by a powerhouse alliance: Airbus, Northrop Grumman, Mitsubishi, Palantir, and now a financial giant from London. The race to replace the ISS is heating up, and it's clear there are two very different approaches. VAST is going fast, lean, and doing it all on its own, trying to get to orbit first. Starlab is moving a bit slower, but it's backed by big industry names and serious Wall Street money, aiming to become the official ISS successor. Both are racing hard, just in different directions with very different resources. And here's the kicker. For the first time, Wall Street is officially betting on a commercial space station. This isn't just about tech billionaires anymore. The stakes are bigger than ever. The International Space Station, a symbol of global cooperation, was originally supposed to be gone by 2016. That was actually part of NASA's 2009 plan, driven by concerns about structural fatigue caused by orbital temperature cycles and constant dynamic loads. So, why is it still up there today? NASA's official explanation is that they want to squeeze as much scientific and technological value out of the ISS as possible. And sure, that's true, but that's not the whole story. The real reason is that technology has advanced so quickly. These days, we see at least 2 crewed launches to the ISS every year, plus 2 or 3 cargo missions. And on every one of those flights, they quietly bring up newer, more advanced hardware to patch, upgrade, or replace aging systems, basically keeping the station alive piece by piece. In fact, on most cargo flights, something like 20 to 30% of the payload isn't science at all, it's home repair. Things like iROSA, the rollout solar arrays, new CO2 scrubbers, upgraded oxygen generation equipment, and even special materials for sealing cracks. And the second reason? It's tied directly to the first. Back in 2010, China officially announced its plan to build the Tiangong space station. Since it was built later, its lifespan will naturally extend far beyond that of the ISS. If the ISS were retired too early, it would leave a vacuum, a monopoly in low Earth orbit that China could easily step into. That's why the partners have been working so hard to keep the ISS alive, not just for science, but to make sure the world still has a presence up there. But there's one thing we can't avoid. No matter how much we patch it up, the ISS is getting old, and the modules suffering the most are the early Russian-built ones. Take Zvezda, for example, the heart of the Russian segment, providing oxygen, power, and propulsion. It's been hit the hardest. Since 2018, small cracks started forming on its outer shell due to material fatigue from extreme temperature cycles in orbit. Air leakage slowly climbed from 200 to 300 grams per day to 400 to 600 grams per day by 2025. Roscosmos and NASA have tried temporary fixes, epoxy sealant, titanium patches, special clamps installed during spacewalks, but new cracks keep appearing. And at this rate, the leakage could reach a dangerous threshold after this year. Or look back at 2021, when Zarya, the very first ISS module, launched in 1998, was found to have surface fractures of its own. They haven't spread yet, but the risk is there, and the only solution so far is constant monitoring. No permanent fix. So the real question is, with the situation getting this urgent, how exactly is Russia supposed to deal with it? The answer becomes even clearer and more alarming when you consider their latest mishap. They accidentally damaged the only launch pad capable of sending Soyuz and Progress missions to the space outpost. More specifically, during the recent launch of Soyuz MS-28, Russia ran into a serious issue at the Baikonur-Soyuz launch pad, a pad that's been in service since the 1960s. Its design is classic Soviet engineering. The rocket stands on a massive concrete structure with a deep flame trench below, while the support arms, umbilicals, and the service cabin sit right underneath the engine section. That service cabin rides on rails and allows technicians to access the bottom of the rocket to hook up cables, inspect the engines, and handle ignition preparations. The problem happened because the cabin, which should have been locked in place, wasn't secured properly before launch. When the Soyuz engines ignited, The high-velocity exhaust created a low-pressure zone inside the flame trench, pulling the cabin out of its hidden position. Its front heat shield acted like a giant sail, catching the airflow and ripping the entire structure off the rails before it was thrown into the flame trench and shattered. With the cabin destroyed, the pad currently can't support any Soyuz or Progress launches. That means Russia has temporarily lost its only launch site capable of sending crew or cargo to the ISS. Roscosmos claims repairs will take just a few weeks, but experts say the damage will need at least half a year to fully restore. And the most immediate consequence: the upcoming Progress resupply mission scheduled for December is now expected to be delayed, which means no new experiments going up and no fresh food shipments either. If during this period any of the Russian modules run into new issues like air leaks, the only hope is that the crew already has enough tools and hardware on board to deal with it. And this isn't just a theoretical worry. As early as 2021, technical assessments from Roscosmos and RSC Energia warned that roughly 80% of the Russian segment systems, including Zvezda, Zarya, and even the Soyuz and Progress vehicles, had already outlived their original design life of 10 to 15 years. That means there's a real risk of cascading failures that can't be fixed from the ground, or even with maintenance flights. Vladimir Solovyov, Energia's chief engineer, put it bluntly: once the systems are fully exhausted, unrepairable failures may begin. By 2023, Roscosmos CEO Yuri Borisov confirmed the warning, stating that most of Russia's ISS hardware is now beyond warranty, and predicting a wave of failures after 2025. This looming risk was a key reason Russia decided to pull out of the ISS partnership in 2028 instead of 2030 to limit liability for these aging systems. Over the years, temporary fixes have been applied, but core systems like the propulsion units and the electron oxygen generator can't be fully replaced. Because of this, NASA has increasingly relied on commercial spacecraft like SpaceX's Dragon, and is also moving forward with a plan to safely deorbit the ISS by 2030 to 2031, ensuring there's no research gap when Russia transitions to its own planned station, ROS. But that's a story for the future. Right now, the bigger worry is whether these aging ISS modules can hold up for the next 2 to 3 years until deorbit. What happens if cracks in the old modules worsen, leading to uncontrolled air leaks? In that case, NASA and Roscosmos would immediately activate the long-planned emergency procedures based on years of prior contingency planning. First, the pressure sensors would detect the problem, and the crew, usually prioritizing the American segment near the evacuation and spacecraft, would close the hatches connecting the Russian modules to the rest of the station. This isolates the affected module, preventing leaks from spreading. Meanwhile, Roscosmos would attempt temporary repairs from inside, though fixing such old systems completely is extremely difficult. If the leak exceeds a critical threshold, the hatches would be sealed permanently, limiting ISS operations, reducing available docking ports, increasing fuel demand to maintain orbit and attitude, but still allowing research to continue in the U.S. segment, with support from commercial spacecraft like SpaceX's Dragon. In the worst-case scenario, if the entire station were threatened by collapse or depressurization, the emergency evacuation plan would kick in. Both American and Russian crew would return to Earth using Crew Dragon. But what about Russian astronauts actually flying on Dragon in the future? That might not be so simple. Just recently, Russian cosmonaut Oleg Artemyev was removed from the Crew 12 mission, set to launch in early 2026 on a SpaceX Crew Dragon. The reason? Alleged violations of U.S. national security rules, ITAR, or the International Traffic in Arms Regulations. Artemyev reportedly took photos of SpaceX engines and sensitive documents at their Hawthorne, California facility, potentially to copy technology. As a result, NASA and Roscosmos replaced him with Andrei Fedyaev. To be clear, this isn't being treated as official espionage, more like an industrial security breach. Whether it was personal curiosity or pressure from Roscosmos to catch up with SpaceX, which Russia once mocked back in the 2000s when Elon Musk tried to buy Russian engines, it's a striking reminder. Flying on Dragon may soon come with extra scrutiny for Russian astronauts. Ironically, the very company Russia once laughed at is now essentially controlling access to the ISS. This also adds a layer of complication to evacuation planning. If the Soyuz launch pad were repaired in time, Russian crew could still use Soyuz for evacuation, with cross-train backup seats already prepared, according to NASA's $224, $266,000 contract with SpaceX to provide Dragon as a contingency support vehicle. What does this all mean? In less than 5 short years, from the crewed Demo 2 flight in May 2020 to the end of 2025, SpaceX has completely shattered the nearly 2-decade monopoly that Soyuz once held. Between 2011 and 2020, NASA paid an average of $80 to $90 million per Soyuz seat, sending over $4 billion straight into Roscosmos's pockets just to get American astronauts to the ISS. But since Crew Dragon became fully operational with Crew 1 in November 2020, the cost per seat has dropped to around $55 to $60 million. That alone has saved NASA at least $1.5 to $2 billion so far, not counting cargo contracts. But the money is just the tip of the iceberg. More alarming for Russia is that Dragon isn't just replacing seats, it's taking over critical tasks that only Russia used to handle. Since 2023, Cargo Dragon has upgraded Draco engines and auxiliary thrusters, performing reboosts that lift the ISS without needing Zvezda. By December 2025, Dragon had already completed 7 independent reboosts, each raising the orbit by 1 to 2 kilometers. In other words, the US could maintain the ISS for 6 to 9 months without a single Russian spacecraft. In August 2025, NASA and SpaceX successfully tested a minimum lifeboat scenario. Just one Crew Dragon docked could evacuate all 7 astronauts in under 45 minutes, instead of waiting for both Soyuz and Dragon. And now, with Baikonur's Site 31 pad offline indefinitely after the Soyuz MS-28 flight, SpaceX isn't just an alternative. It has become Roscosmos's only lifeline. If the situation drags past March 2026, we could witness a historic first. A Crew Dragon lifting off from Florida carrying 2 or 3 Russian astronauts to save the Russian segment of the ISS, something unimaginable just a decade ago. Right now, getting launches back on track is a real headache for Russia. The first hurdle is simple in theory, but tricky in practice. Technicians need access to the base of the rocket to reconnect all essential cables and equipment.